Hello and welcome to this video on conversion graphs. As the name suggests, you are converting between two things, mostly measurements and currency. That's what you'll mostly encounter when you look at conversion graphs. So let's have a look at an example. It says the graph below converts amounts of money between pounds and euros. It says showing clearly where you take your readings, work out how many euros are equivalent to £50. Now what that means there in green highlighting, showing clearly where you take your readings, it means you need to use a ruler and a pencil to read off the graph. If you don't do this, you will not get the mark in the exam. So you need to get a ruler and a pencil and you need to read off that line. So we are reading off where it is £50, so go to £50, pounds is on the horizontal axis, go to 50 and you're drawing a straight line with a ruler and a pencil up to that line. And then you are going to where it hits and then reading across. So what does that read off as on the scale? Well, looking at the scale here, I've got 40 and I've got 60. So I'm going a jump of 20 euros in 10 equal little squares, which means each square is worth 2. So this point here is 58. So how many euros are equivalent to £50? 58 euros. Part B says use your answer to part IA to write down how many euros are equivalent to £100. Well, if 58 euros are equivalent to £50, I'm just going to double it. So I'm going to double my 58 to get how many are equivalent to £100. So 116. Part C, by considering how many euros are equivalent to £1, write down the exchange rate between pounds and euros. So they're trying to get you to use this question that you've just done here in part B. So if you know that £100 is equal to 116 euros, then £1 is going to be equal to 116 divided by 100, which means 1.16. And this is normally the way that currency exchange rates are written. They're normally written £1 is equivalent to some other currency, in this case euros. So £1 is equivalent to 1.16 euros. That is how currency conversion rates are normally given. £1 is equivalent to some other amount of currency. Okay, part 2, showing clearly where you take your reading. So again, we're going to need that ruler and pencil to read off this graph. Use the graph to answer the following questions. While on holiday, Mr. Smith pays 45 euros for a train ticket. How much does the ticket cost in pounds? So again, you're going to use a ruler and a pencil, and you're going to go across this time though at 45 euros. So we've got to interpret this scale again. So 45, well, halfway between 40 and 60 would be 50. So this point here would be 50, but I need 45, so I'm going to go across halfway between 40 and 50, which would be a bit more accurate than that, would be here. And then I'm going to read down the graph. Okay, it's not quite on an exact value, but I'm going to say that's 39. That's pretty much 39. So that's 39 there, £39. Because it does say give your answer correct to the nearest pound. And in this case, I think it's nearest to 39. Mr. Smith can buy a watch for £62 in London or 75 euros in Berlin. Where is it cheaper to buy the watch and by how many euros? Now a little exam tip here. If it's asking you to work out by how many euros something is cheaper, then you need to convert the one in the question that is not yet in euros. So the £62 watch in London is not yet in terms of euros. So that is what you need to convert into euros. So I'm going to do £62. So find 62 on your scale, go up and read across. And that reads as how many euros? Well, 60, that's 70, 72 euros. So I'm just going to make a little note to myself that £62 is equivalent to 72 euros. It says, where is it cheaper to buy the watch and by how many euros? Well, if it's 72 euros in London and 75 euros in Berlin, then it is cheaper to buy it in London, and it's cheaper by 3 euros. Because that's the difference between 75 and 72. Okay, example number 2. In this question, 75 miles is the same distance as 120 kilometres. Now that opening sentence is crucial for you to be able to do the rest of this question, okay? So this sentence here, really, really important. 75 miles is the same distance as 120 kilometres. That means that you need to plot a coordinate that I've got going on here on this graph. Okay, so 75 miles, well, I'm going to go across my 75 miles. 75 miles is there. And 120 kilometres, so I'm going to go up to 120 kilometres. 120 kilometres is, well, that's 100. My scale is, well, 2 squares is 10, so that's 110, 120. There's my 120. So that is where your coordinate is. And then you're going to draw a straight line going from 0, 0 through that red cross. Some students just think that you draw a straight line right across the graph paper. You don't do that, okay? Don't just assume that you're going to go from one bottom corner to top corner and that that's your line graph. No, you've got to go through that coordinate, okay? It's absolutely essential that you go through that coordinate and the point 0, 0 down here. I'm just going to make sure my line goes absolutely through that coordinates. So that is now your conversion line. Okay, we've used the fact that we've got in this question here 75 miles is the same distance as 120 kilometres. So I did 75, 120 and drew my straight line through it. Showing clearly where you take your readings, convert 40 miles into kilometres. So again, you need to get that ruler and pencil out and you need to go up at 40 miles and read across from your graph. So you can see how important it is to get this coordinate correct and to get that line accurate, because all of the rest of your questions depend on that. So 40 miles into kilometres, well, that's 50, that is 65, okay, 65 kilometres. Convert 35 kilometres into miles, so I am going to go this way round this time, so 35 kilometres, so 10, 20, 35, that's 35, go to your line, and then read off. Read down, that's going up in 2s, that's 22. 22 miles. Part 3. Maya estimates that she lives 80 kilometres from her friend Fran. Fran estimates that she lives 90 kilometres from Maya. They actually live exactly 55 miles apart. Who made the closer estimate? Give a reason for your answer, okay? So all you need to do is convert them both to the same unit, in this case miles, because this is your reference point. It says in the question they actually live 55 miles apart, so that is the unit that you need to convert it to. So you're going to use your graph again, use the graph, go across at 80 kilometres, because that's what Maya's estimated, so 80 kilometres is here, 80, and you go down here and you find that it is 50 miles. Make a little note of it. So 80 kilometres is 50 miles. And then again, read off the graph again using a different colour. 90 kilometres is here. Read off your graph and you get that is 56 miles, because each square is 2, so 52, 54, 56, that's 56. So the 90 kilometre estimate is 56 miles. So who made the closer estimate? Well, we're told that they live exactly 55 miles apart, so therefore who's closer? Fran's estimate of 56 miles is close because it's only 1 mile away from the target. So Fran, because her estimate was only 1 mile more than the actual distance. Okay, and another example where you've got to plot the points. It says 12 metres is approximately the same length as 40 feet. So you're going to use your coordinate 12 metres, 40 feet. There's 12 metres, there's 40 feet. That is your coordinate. Okay, please don't be tempted to just draw a straight line from the bottom part of the graph to the top part of the graph and hope for the best. No, you've got to do it through that point. Draw a graph to convert the lengths up to 12 metres. Well, we've done that. Showing clearly where you take your readings, answer the following questions. Nico's car is 4.5 metres long. What's its length in feet? So get a pencil and a ruler and go up 4.5. Well, that's 5 metres. So 4.5 is here. Go up to where it hits the graph, read off, and you'll find it's exactly between 10 and 20. So that is 15 feet. Part B, Roman's yacht is 35 feet long. What is this length in metres? So go across at 35 feet. 35 feet is between, obviously, halfway between 30 and 40. Read across to where you hit the graph. Read down. And that is just over 10.4. I'm going to call that 10.4 metres. C. Monica jumps 30 feet in a triple jump competition. Naomi jumps 8.4 metres in the same competition. Who jumps further and by how many feet? So again, little exam tip there. If it says by how many feet, then you need to change the one that is not in feet into feet. Okay, so 8.4 metres into feet. Let's do that. 8.4, well, that's 9, so each one is 0.2, so that's 8.2, 8.4. 8.4, go up to where it hits the graph. Read across, and you find out that that is 28 feet. So that is 28 feet. So if Monica's jumped 30 feet and Naomi has jumped 28 feet, Monica jumps further by 2 feet. Okay, there are some examples for you, and here is a question for you to have a go at by yourself. So I appreciate it's quite difficult to do this, so you might need to print it out or draw it out as best you can. So pause the video now, have a go at it, and then resume the video to see the answers. And here is the answer. Well done for having a go at those.